Hello everyone, my name is Carl Vincent Blitzlingat and I am going to give an overview of pointers in CCPROG1. To understand what pointers are, we need to first understand that a variable upon initialization is usually assigned two things, and that is a value and an address. The value is what the variable contains and the address is where the variable is located somewhere in the computer's memory. This is very helpful in solving problems in CCPROG1 in which I will be showing you later on. So before we start, we need to know that pointers store the memory address of a variable. Again, pointers store the memory address of a variable. So in this demonstration, let us declare an integer variable named nval and assign it a value of 10. Now, let us declare a pointer variable named pval. To do this, we need to use the asterisk operator and put it beside either the data type or the variable identifier itself. Remember that a pointer variable contains the address of the variable of the same data type. In this demonstration, we want to store the address of nval into pval, which is why I used integer here, since nval's data type is also an integer. Okay? So, to assign an address to a pointer after initialization, we have to use the ampersand symbol on the name of the variable whose address we want to store. So in this case, it is nval. So now what is happening here is that the ampersand operator allows us to access the memory address of nval. And since this is an assignment statement, we store the address of nval into pval. So let me show you that the variables nval and pval contain what we assigned to them. So printf nval %d\n nval, and then printf pval %p. By the way, the data placeholder for a pointer variable is the %p. Okay, so /n then pval. Let us run the program. There we go. Nval contains 10 and pval contains 62fe14. So that is exactly what we assigned to them. But just to be really sure, let me just show you that pval really contains the address of nval. So printf address of nval %p/n. And then now we use nval. Remember that using the ampersand symbol will allow us to access the memory address of nval. So let us run this program now. And there we go. They are exactly the same. So we can confirm that pval contains the address of nval. So the value of pval or the address of nval may not be the same as the one that you're seeing on screen because it depends on the system you're using. So essentially, your computer might store it in a different address compared to mine. So please do take note of that. Now, I have to show you that assigning the address of a variable to a pointer variable upon initialization is different from assigning anywhere else in the program. Let me first remove the assignment statement here and assign the value outside the initialization. So pval ampersand nval. So let us see if this will give us the same output as last time. All right, there we go. So it's exactly the same. So now, I bet you're wondering why I did not include the asterisk symbol beside pval. Well, I'll discuss that shortly for now. But for now, you already know how to declare, assign, and print a pointer variable. Now, I will be showing you what we can do with pointers, at least in CCPROG1. Remember that I did not include an asterisk operator in that assignment statement. It is because what the asterisk operator does is that it accesses the actual value outside. It accesses the actual value that the memory contains. Again, it accesses the actual value that the memory contains. This process is called dereferencing. It essentially morphs or turns a pointer variable into a regular variable that we know. Again, it essentially morphs or turns a pointer variable into a regular variable that we know. Let me show you just that. So first, let me remove that, or else it will cause some weird things to happen. And then print if pval %d/n. Again, because what asterisk does is that it morphs the regular variable, or rather a pointer variable, into a regular variable. So pval, and let us try to run the program. And there we go. So for CCPROG1, I'd like to think that when we dereference a pointer variable, it becomes an ordinary variable where we can do our normal operations like assigning and addition, subtraction, and the likes. Look at the output on the screen. You can see that pval, without any other operators, contain the memory location of nval, which for the sake of simplicity would be called FE14. Since pval contains the memory of nval, when we do referencing to that pval, we are also accessing the value of nval, because the referencing pval is actually accessing the contents of nval by directly accessing what the memory of nval contains. If you are confused with what I said, think it of it this way. When we dereference a pointer variable, it essentially becomes the same variable where we assigned its address to the pointer. In this example, when we dereference pval, it actually acts like nval. Pause the video, play back, and perhaps give yourself some time to process that information, as it is a bit tricky to understand for novice programmers. Now, what happens when we use the ampersand operator on a pointer variable? Well, it will just access the address of that pointer variable. Remember, the ampersand operator is used to access the address, while the asterisk is to dereference or access the actual value that the address contains. So let me show you just that. So printf address of pval %p. Then since we want to access the address of pval, we use the ampersand operator. Then there we go. All right. Now this is the address of pval. So I hope you got the gist of pointers by now, and it is finally time to show you the usefulness of pointers. As far as I remember in CCPROG1, pointers are used to modify values of the variables located inside main via functions, or rather, pointers are used to modify the values of the variables located inside main through or inside functions. Remember that whatever variables in a function will only cover or be used inside that function and not in main. And after their execution, the variables essentially restart if we are to call it again. Allow me to code just that, but let me remove the printf statements just to declutter. So there we go. Oops. All right. So now let us create our function first. So void function int, then let's call it the parameter and nval. Then nval is equals to 15. Then printf value of nval is percent d slash n, then nval. So I am just coding what I meant by functions will only, the variables in functions will only cover or be used inside that function, and it will restart. It will restart after we call them. So we have to, for this demonstration, we have to print nval again. So initial value of nval percent d slash n, then nval. Then let's call function nval. Then printf value of nval after calling the function percent d slash n, then nval. Let us now run this program. All right. As you can see, the value of nval in main is not affected by the assignment statement inside the function. So just to make sure that the idea that using the dereference operator will change a pointer variable into a regular variable, let me show you this. So let me close this. So asterisk pval. All right. There we go. We have exactly the same results. All right. So now it works because what we're passing is an integer thanks to the asterisk operator, which allows us to access the actual value, not the memory address. So essentially, we are passing an integer value to the function. Now, what if we can change the actual value of nval inside main through the function? Well, we have to first change the parameters that this function accepts. Instead of an integer value, we add an asterisk operator to indicate that the function will accept a pointer value. Remember that the asterisk operator can indicate either a pointer variable, but only during variable initialization, or a parameter, and the other is dereferencing or accessing the actual value of the memory throughout the rest of the program. Again, the asterisk operator can indicate either a pointer variable, but only during variable initialization or parameter, and the other is dereferencing or access the actual value of the memory throughout the rest of the program. So now, let me show you just that. So printf initial value of nval in the function percent and then nval. Okay. So passing this would not simply work because this is actually a pointer variable this time. So what we are going to do is to use the asterisk operator here, and then here this won't work as well because what we're passing here is an integer value, but when in reality we need to pass a pointer value. So we need to remove this asterisk operator so that we can actually pass the pointer value or the memory address. So if we fail to do so, weird things will happen. So again, what I'm doing here is that I am passing a memory address to a function so that we can change what that memory address is storing. So now, let me just run the program. Oops, what happened? Okay, I forgot. Add the ampersand, or sorry, the asterisk operator. Okay. So, there we go. As you can see, initial value of nval is 10. So we pass the address of nval via pval to the function. So initial value of nval in the function is 10. Then we assign the value of nval inside the function to 15. Now, after assigning that, when we print it out, value of nval, it becomes 15. And then when we go back to main, because the function is already done executing, value of nval after calling the function is 15. What happened here is that I passed the address of nval, which is stored in pval, into function. Okay? So I printed out the referenced value of nval right here. By the way, I would like to tell you that this nval is actually a pointer variable and not a regular variable. So that's why this asterisk operators here are necessary. Again, so after passing the address, what we did here is change what that address contains, which is precisely why this assignment of statement changed the value of nval in main. So let me give you oops. So let me give you an analogy as to what happened. Let's say I have a money jar and I will put some money inside it. When I give it to another person, at least in the context of functions, what I am giving them is a copy of my money jar. So what that person does to the money jar will not affect my money jar. But for pointers, what I will be passing is my own money jar. So that means that whatever the person does to that money jar will affect my very own. Giving the copy of a money jar to another person is what we call pass by value, which means that the function only receives a copy of the value or a variable, and what happens in that function stays there. Pass by reference, however, is where the function receives the address of a variable in which it will be able to actually change its contents, which will affect the original variable in main. All right, I hope you finally get the gist of pointers by now. And let me demonstrate a problem in which pointers would be extremely useful. So it says here, swap the values of two variables in main using a function. We can solve this through the use of pointers. So first, let us declare two integer variables in which values we want to swap. So int a, then let's assign it the value of 10. Int b, then assign it the value of 10. Now let us declare a pointer variable named pa, which will hold the address of a, and then int pb, which will hold the address of b. All right. Now let us create a function named swap, and its parameters being two pointer variables, and its return type being void, since we just want to swap the variable values. So void swap int a, int b, all right, then temp. Now let us declare an integer variable named temp, because remember, when we assign a new value to a variable, the original value that the variable used to contain will be lost. All right. So let us do just that. All right. Now let us assign the value of the reference a to 10. We need the ampersand operator here because the pointer variables have already been declared via the parameters. Okay. And by doing so, we are just morphing a into a regular variable. Now let us assign the value of the reference b with a with the value of the reference b, and then b with the value of them, which contains the value of a. All right. again, what is happening here is that we decided to store the value of the reference A into temp first, so that when we do this, we won't lose the value or the original value of A. All right? And that temp variable is holding that original value for us. So now let us finally print the values and in main and call the function as well. So printf value of A %B, value of B %B, /n AB. Then swap PA, PB. Then finally printf value of A %B, value of B %B /n AB. I will just put here after calling swap. All right. Now let us run the program and see if it will swap. There we go. We have successfully swapped the values of A and B. So in this swap call, remember that we do not need to put an asterisk operator here. Why? Because what we wanted to pass to swap are pointer variables. And since P and PB are pointer variables by themselves, we do not need to use the asterisk operator or the ampersand operator. So now, what essentially happened is that we pass the addresses of A and B through PA and PV to swap. And then the asterisk operators here allowed us to access the memory, the address value, the value that the address contains directly, which made this swap possible. So now, if you notice, we can also just pass the address of A and B by themselves in the function call using the ampersand operator. Because this one, again, gives us the address of a variable. And now, let me just run the program. And there we go. We have the same outputs as last time. All right. Now, to summarize everything, pointers are variables that contain the memory address of another variable. We need to use the asterisk operator in the variable initialization in order to declare that it is a pointer variable. When we use the asterisk operator outside initialization, like for example this one, what we are doing is the referencing or accessing the variable directly. When we use the percent operator on any variable, we are accessing their address or referencing. That would be all for now. Thank you so much for listening and good luck in your assessments.